Good morning, fourth graders. Welcome to another episode of How Many Tabs Are Open on Mr. Johnson's Computer? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Too many tabs open on Mr. Johnson's computer. So 11 tabs. Let's take a look at today's assignment. Looks like we're doing some identification of lines and angles. So I'm taking what we have learned and taking it to the next level. And this is all stuff that you'll need for fifth grade. A lot of these terms you will use over and over in fifth grade. For instance, parallel lines. All right, that's a fifth grade term for sure. You've probably learned this before. An example of parallel lines is actually in the word parallel. All right, what I mean by that is if you take a look, the L's in parallel are parallel. Parallel lines means two lines that go straight forever, side by side, and never touch. All right, so like those railroad track lines, those would go straight forever and never touch. So they never intersect. So parallel lines never intersect. And oops, and in the phrase or in the word parallel, you can literally see parallel lines. All right, so that's a cool thing. So two lines lie in the same plane and never intersect each other. So they go on forever and they never touch. That could also be like sideways. So it does not have to be just like straight up and down. It could be side by side. All right, so perpendicular lines. Perpendicular lines are a very, very, very special intersecting line. So maybe we should talk about intersecting lines first. Intersecting lines are just any time where two lines meet. All right, that's an intersection. All right, anytime two lines cross paths, that's an intersection. So parallels do not cross, but intersecting lines do cross. Now, if they intersect at a very special right angle, 90-degree angle, if they intersect at a 90-degree angle, that makes them a special, special thing called a perpendicular line. All right, so any two lines that cross paths are intersecting. If they intersect at a 90-degree angle, you have a perpendicular intersection. Perpendicular. It's a fun word, lots of syllables. All right, perpendicular lines. Two lines that intersect at a 90-degree or a right angle. Intersecting lines, just any angle you want. All right, so if we're looking at this, here's some example of parallel lines. You have those two boards going this way, parallel forever. More parallel lines, two going this way forever. More parallel lines, these are going on forever. So intersecting, here are some intersections. Those do not create a 90-degree angle. So that's why I'm saying that it's just intersecting. Right there is not a 90-degree angle. Here, you do not see 90-degree angles. Here, you do not see 90-degree angles. So those are intersecting. And then finally, perpendicular. Right here, you can see a 90-degree angle. Yeah, I can even put that little plus right there. Ooh, perfect 90-degree angle, right? Here's another one right here. You see how I can line up the parts of my little cursor to where they fit perfectly in that corner. So we're looking for corners, right? We're looking for those 90-degree angles for our perpendicular examples. All right, so let's take a look and see where we can find parallel lines going on side by side forever, perpendicular lines intersecting at a 90-degree angle, or intersecting lines, just two lines that cross each other at any angle. All right, so study the figure below. Which pair of two lines appears to be parallel? And remember, in parallel, you got those two L's going side by side. It's an example of parallel. So do you see two lines that are going side by side and will never touch? Two lines that look like lowercase L's next to each other. Line P and line Q are crossing. Line R goes straight up and down. Line S goes straight up and down. Do you think R and S will ever touch with their current direction? Or do you think they'll just go on straight forever? If you think they'll go on straight forever, I'd agree with you. Those look like parallel lines. Lines R and S go on straight, side by side, and they'll never touch. All right? Okay, so let's take a look at the next part. Study the figure below. Which pair of two lines appear to be perpendicular? All right, so getting the corner of your page might be a good idea for this one. The corner of your page, if you just want to put it against your screen, see if I do this, you're not going to be able to see it. But find find a place where the corner of your page, the corner of a piece of paper fits. all right, and find out which two lines are intersecting at that fit, because there are four right angles to be found on this picture. All right. So if you're looking for the right angles, here's one, here's one, here's one, and then here's one. So all of those angles have two lines in common. We have line L that's going this way, and line N that is going this way. And as you can see, if we stuck the corner of a piece of paper into this right here, it would fit perfectly. You could draw one of those squares right there, because that is a 90-degree angle. All right, so line L and line N make 90-degree angles. Here's one, here's two, here's three, here is four. So lines L and N give us some 90-degree angles. All right, study the figure below. Which of the following describes the figure? Remember, if it starts in one place and then goes on forever, we have a dot on this side and an arrow on this side. Think about the sun and drawing pictures of the sun when you were little. What were those lines that came off the sun? They started at the sun and then they came off the sun. Yeah, sun ray. All right, so a ray is a line that starts on one side at a definite point and then goes on forever with the arrow in the opposite direction. Okay, so page 3, study the rectangle below, then answer the questions on the bottom. All right, so we have a rectangle with point A, B, D, F. All right, so name the two sides that appear to be parallel. All right, so I don't think that there's any wrong answers on this one. Well, there are some wrong answers, but there's a lot of right answers too. B and F, BF are parallel with AD. So if you wanted to write BF is parallel to AD, or you could have said that the line AB is parallel to DF. AB is parallel to DF. All right, so there were two sets of parallel lines. You had the AD and BF over here being parallel up and down, or you have AB and DF over here being parallel from left to right or horizontally. All right, so basically, if you think about it, like this line, oops, this line would go on forever this way, right? And then that's AB, and then DF would go on forever that way, even though I didn't line that up perfectly, and that one's not straight. But same idea. Those are the lines AB and DF, and those are what should go on forever. Okay, so name two sides that appear to be perpendicular. This is the one that doesn't make as much sense right away. So like if you are like a fourth grader, this might not be something that you see right away. So let me show you how to see it. All right, so there's line segment BF. Now let's look at line segment AB. So now that we've done that, let me make a little box and we can test our theory with our box. All right, so here's my rectangle. All right, so what I want to do is I want to see if my rectangle or my corner of my page fits perfectly in each corner. Does that fit perfectly right here? Yes. Does that fit perfectly in this angle right here? Yes. You can also fit it over here. Does it fit perfectly? Yes. So what it suggests by fitting perfectly in all the different corners is that we have a 90-degree intersection, which is called a perpendicular intersection. So you also have two answers for number 2. Name two sides that appear to be perpendicular. On this one, I talked about side AF or AB and BF. AB and BF are perpendicular. All right. You could have also said AD and DF. All right. AD and DF would have been the same idea, but if we just moved our line segment or our lines this way, right? And now we can still see that there is a perpendicular intersection right there. And that's why I drew these lines, is so you could see that you have that 90-degree intersection. Even though like you're like, well, the line stops at the corner of the rectangle, there's like an invisible line still going like straight through, and that's making these 90-degree intersections or perpendicular intersections. All right, so AB and BF, or the other one was AD and BF. All right, um, so that gives you two options: AB and BF, AB, BF, or AD, DF were the perpendicular intersections. All right, let's take a look. Oh, that one's too big. All right, let me shrink this down. Okay, so what we have to do is identify lines and angles. We are going to try and categorize all of these pictures on the left with our Venn diagram over here on the right. So remember, everything that's parallel will fit over here. Everything that has perpendicular will fit on the right side. And if they have both parallel and perpendicular intersections, they will fit in the middle of the Venn diagram. All right. So parallel sides and perpendicular sides. This one looks like it has both, right? Because the lines on the outside will go on forever, but in the middle, we do have a perpendicular intersection. All right. Another perpendicular looks like a baseball diamond, right? The lines from the baseball diamond intersect at home plate at a 90-degree angle. That's perpendicular. Do you see any other intersections at a 90-degree angle? Yeah, there's a lot of them, right? And some of these will have parallel and perpendicular. Like, once again, that tile, you have parallel lines going sideways, and then you have the perpendicular lines at the corners, right? So both sides of the tile are parallel, but in those corners, you have those perpendicular intersections, all right? Over here, railroad crossing, we have perpendicular, right? These two things are crossing, the two parts of the sign are crossing at a 90-degree angle. We could put the corner of a piece of paper in this angle and it would fit perfectly. All right. Here's another one that has both. If you think about it, railroad tracks, the tracks from side by side go on forever parallel. But where those crossbars go over, that's perpendicular. All right. This looks like a perpendicular intersection. I don't see any parallel because these on the sides look to be curved. Curves don't often, you will not be dealing with curves in geometry in fourth grade. All right, let's take a look at a football field. A football field would also have both, right? Because the edges of the football field, the sidelines are parallel, the end zones are parallel, but then you have all of those intersections at the yard markers and everything like that, the perpendicular intersections. So I'm going to throw this one in the middle. All right, this one, once again, we have the parallel lines, which are the track lanes themselves, but then you have these cross lines, right, that make the 90-degree intersections. So anytime you're seeing those like 90-degree intersections, those crossing points, remember that you have parallel. Um, if you have parallel, you also have perpendicular. So there are both in this one. All right, this one's a little funky. I think what they were trying to say is that these were, see, these aren't perpendicular because it's not a 90-degree angle, and they're also not parallel because they're not going on forever. So I would almost just leave this one by itself. And I'm also kind of wondering, is there going to be, okay, here's some parallel. There we go. These are not perpendicular. Those are some lines that are just going straight up and down. All of those windmills side by side by side, we have parallel, all right? Um, on the Golden Gate Bridge, once again, we have both, right? Straight up and down in these columns, but the road also makes it a perpendicular intersection. So we have both, all right? A lot of these things are just going to have both. Um, if you look at the window pattern, the framing is parallel, side and side is parallel. Some of these are parallel, but you also have these 90-degree intersections where the plus fits perfectly, right? Like right there with the wood and the framing, or like in the window little pane part, you see another 90-degree intersection or a perpendicular intersection. So we have a lot of these that go in the middle. This one, It doesn't look like we have any parallel lines. It looks like a intersection. I guess you could consider the sides of the road parallel, but for the most part, we could just say that this one is perpendicular because it looks like it is crossing at a 90-degree angle. You could put a piece of paper in that corner and it would fit perfectly. Um, and then this one over here, you have a lot of parallel lines and you have intersecting perpendicular lines. All right, once again, you do have where your horizontal and your vertical lines are going to be crossing at a 90-degree angle. So this is going to be a little bit of both. And then once again, the house is just full of both intersecting and parallel lines, like the studs on these boards and things like that. They're going up and down, but they also have like parts that are crossing over from side to side. So there's going to be a lot of 90-degree intersections. All right. So a lot of the times you're going to find out that there are also parallel and perpendicular lines and angles in the same place. All right. The only one that was really easy to be like, that's all 100% parallel was the windmills because you have them going like side by side by side. They might have wanted to tell you that the train tracks are parallel, or they could be both. Remember the tracks themselves go on forever and never touch, but you also have those cross parts, right? These little pieces of wood that will cross the 90-degree angles or the parallel lines at a 90-degree angle. So you've got a lot going on with the train tracks. They should have just used a straight train track. This gets a little bit confusing. So that's why I'm just going to leave it out here. If you want to leave it out there, cool. If you just want to be like, they meant that they were parallel and perpendicular. If they're both, they go in the middle, right? We're running out of room in the middle though. So you can, that one's kind of a freebie. So put it where you want to put it. If you want to just think about train tracks going on forever, cool. If you want to think about each little individual part crossing over as well, that would put it in the middle. So either parallel or in the middle. All right, final. Let's see. Look at the figure shown below. Which line segments appear to be parallel? All right. So we are looking for any two line segments, so from one point to one point, that will go on forever and never touch. If you look, this BC line right here goes on sideways from side to side. And this FE line does the same thing. So BC goes on forever from side to side. FE goes on. So BC and FE are parallel. And then also we have AF and CD being parallel. Sorry, my lines are wonky right there. That should have been straight. But AF and CD are going straight up and down. So those are parallel as well. A and F and C and D. So we're looking for BC, FE, BC, FE, and then we're looking for AF, CD, AF, CD. So we have two sets of parallel lines in this image. We have AF and CD, which will go on forever up and down, and we have BC, FE, which will go on forever side to side. All right, which line segments appear to be perpendicular? So my hint on this one with perpendicular is just look for a place where the corner of your page could go. Do you see any places where a corner of your page would fit perfectly? All right, so if I want to draw like a little square, here's my square. Let me try and figure out places where the corner of my page will fit perfectly. So I think right here it would work, right? Fits perfectly. Looks pretty good, right? So I think AFFE is a perpendicular intersection. And then let's see if this will fit perfectly also in this corner. Oops. This is easier to do in real life with a real piece of paper than it is on your Google document or your Google sheet. So bear with me. I think we'll get it. Okay. It's about as close as we're gonna get. Um, in real life, once again, it'll be way easier because you can just adjust it without using a mouse. But basically, the corner of our piece of paper should fit perfectly in there, and it almost is. It really would if it was a normal piece of paper, but I can't seem to get it to turn exactly the way that I wish it would turn on this application. So, um, but that would mean that also CD and DE is also going to be a 90-degree intersection. So AF, FE right here is a 90-degree intersection. CD, DE right here in that corner is your other 90-degree intersection. So those are both perpendicular because they're at 90 degrees. So AFFE, and then do we have one that says ED, DC, ED, DC, AF, FE? So we do. B represents both spots with CD, DE, and with AF, FE. And those are our two 90-degree angles. So that should get you to the end of this one. Ask your teachers if you have any questions. Feel free to reach out if you need some help. I hope that this is kind of working out for you and making sense. Your teachers should be back soon, so hopefully that'll help as well. And yeah, I hope you have a good day, and I'll see you later. Have a good one. Bye.